Welcome, everyone. In this lesson, we're going to go back to our differentiation technique topic. And we're going to see a few more derivative rules. And in this lesson, we're going to be looking at the product and quotient rules. And we're going to start with the product rule. And what this rule does, we have the formula here, but what this rule does is it tells us how to differentiate the product of two functions. And that's really what we have here. If we kind of start reading through this formula, we're trying to differentiate with respect to variable x. And what we have is one function, capital F of x, times another function, capital S of x. So what we have here, even though it's not explicitly written, there's multiplication there. So unfortunately, multiplication doesn't kind of play as nice with derivatives as addition and subtraction. And so that's why we have this special rule. And so what we have, when we look at this function that we're trying to differentiate over on this left side, is we have a product of two x terms, two functions of x. So here's a function where we might have some x terms. And we have a second function where we have some x terms, and we're multiplying those together. And this formula tells us how this derivative process works. And so the way we actually differentiate this product is that it ends up being the derivative of the first function times the second function unchanged. And then we add to that the first function untouched times the derivative of the second function. So a way to kind of shorten this formula up notationally is, let's say we have our two functions, and I'll write in the multiplication here, and we're trying to differentiate this whole thing. Well, the way the product rule works, and the way we'll kind of think of it in our example, is that we're just going to write this product twice. We're going to write two copies of it. So we'll have one copy of our function, f of x times s of x, and then we'll write a second copy over here. And then in between these two, we're going to put a plus sign. And then in the first copy, we're going to differentiate just the first function. And in the second copy, we're going to differentiate just the second function. So kind of doing it with this format is actually going to help us later on when we go to the quotient rule, because it's going to be very similar. So this is the way we're going to think of the product rule here. Now, just a word of caution. So we're gonna try an example, and let's actually try the example first, and then we'll come back and we'll do the warning, because it's easy to get these derivatives of products and quotients. It's easy to get them wrong, and it's very tempting to, and we'll come back and explain that a little bit further. So let's try an example where we actually differentiate a product of two functions. So example 1, we're going to differentiate this function, and it's given as y equal to 2x cubed minus 5x times 3x plus 1. Now again, it's not explicitly written with a multiplication symbol in between, but technically that's what's going on here, is we're multiplying. So there's some multiplication happening here. And when we look on either side of that multiplication, there are variable terms over here. So there's some x's there. And then there's also some variable terms over here. So we're multiplying two functions of x. So we're going to use product rule. So we have one function of x times another function of x. All right, so let's see how the product rule works. Let's see it in action here with a real example. So we're going to calculate y prime, And the way we're going to implement the product rule is just write 2 copies of our function. So we'll put 1 copy, 2x cubed minus 5x times 3x plus 1. There we go. Got 1 copy there. And then let's do another copy. 2x cubed minus 5x times 3x plus 1. And then we throw a plus sign in between those 2 different copies. And in the first copy here, we're going to differentiate just the first part of our function. So we're going to apply the derivative to just that first part. And then in the second copy, we're going to apply the derivative to just the second part. And that's the product rule. That's what the product rule says. So all that's left for us to do then is just to finish up differentiating this term and differentiating this term. And to do these are just regular polynomials that we've been differentiating the whole time we've been doing derivatives, basically. So these should be kind of old hat at this point. All right, so let's see what we get. Derivative of 2x cubed, we do some power rule, bring the 3 down, multiply it with the 2, so we get 6x, and then we subtract 1 in the exponent, so that gives us a squared. And then the derivative of minus 5x is just going to be minus 5. And then that differentiates this whole thing, so we're done there. This is outside the brackets, so we don't have to do anything there as well. So we're going to have times 3x plus 1. Then we have our plus sign. This is also outside brackets, so we don't have to do anything there. So we'll have our 2x cubed minus 5x. And then the only thing left to do is differentiate this other term. And derivative of 3x is 3. And derivative of plus 1 all by itself there is just going to be 0. So we end up with times 3. And there's our derivative, y prime. If we wanted to, we could go further and simplify this down by multiplying everything out, but we're just going to stop there. So we're done with all the derivative, all the differentiation. We can stop. We have our derivative. All right, so that's the product rule in action. The product rule happened in this step right here. That was us applying the product rule. And then to get the answer, then it was just some regular derivatives that we've done. All right, so let's go back to our kind of our word of caution. And actually, before we do that, let's look at this. Let's look at this one, the way we differentiated this. So here we have subtraction. And differentiation works really nice with subtraction and addition because we can just differentiate each individual term and that's it. There's kind of no extended formula or anything. So just to make a little note here as we're thinking about the product rule. We know that when we differentiate, so say we have one function f of x plus or minus another function s of x, and we wanted to differentiate this whole thing. Well, the way we differentiate that is kind of look at the first term, differentiate that on its own. So we get f of x, and we just do the derivative of just that part. We keep the addition or subtraction sign in between. And then we also look at the second function, s of x, and we just differentiate that all on its own. And we called this term-by-term differentiation. So when we have a plus or a minus in between two variable terms, we can just focus in on each variable term and kind of work our way down the line there. So this was our sum rule. And this is what we've been doing all along. All right, but it turns out multiplication or products of two functions behaves differently. Doesn't work as nicely with derivatives. So just a note here to be careful. It's very tempting, but incorrect to say if we have two functions, f times s, and we're doing a product here, it's very tempting to say that this product, if we wanted to differentiate, is just the product of the first function times the product of the second function. So it's really tempting to say this. It kind of fits in line with what we know about addition and subtraction. We just do the first function, do the second function, and then the plus sign or minus sign just stays the same. Unfortunately, it doesn't work this way with multiplication or division. So no, this doesn't work out. It's very tempting, but it's wrong. We can't do this. So instead of trying this, and very plausible idea, this would seem to make sense. So it's definitely tempting, but unfortunately multiplication doesn't work out that way. And instead, we have to use this extended product rule. And this actually calculates the derivative for us. All right. So with this in mind, we'll save some examples for class, but we're going to jump over to the quotient rule. And we'll see this. We're going to first look at the rule, and then we'll try an example. And we're going to have the same warning when we do the quotient rule. So first of all, what is this rule? Well, it tells us how to differentiate when we have the quotient of two functions. So we have one function being divided by another function. So we have a fraction. So that's really what we have here. We have one function, another function, and right down the middle there, we're dividing. So we have a fraction. So a lot of times when we're going through, if we see a fraction, well, we should start thinking, well, maybe we have to use this special quotient rule to help us with the derivative. And we really only need to use the quotient rule if we have a fraction and there's variable terms on both the top and the bottom. All right, so what does this derivative rule tell us? Well, if we have a function, capital F of x, being divided by a second function, capital S of x, and we want to differentiate that whole quotient, that whole fraction there, quotient rule says you differentiate the top function first, times the bottom function unchanged, then you subtract, and then you have the top function unchanged multiplied with the derivative of the bottom function. And then you're still going to have a fraction here, and then you square the original denominator. And so the way we're going to kind of implement the quotient rule is going to be very similar to how we did the product rule. So let's kind of look at the shorthand notation that we're going to use. So we have our fraction, and we're trying to differentiate this whole thing. Well, we're going to implement the quotient rule just very similar to how we did the product rule. So we're going to write this fraction as a product. So it'll be the top function times the bottom function. And just like how we did with the product rule, we're just going to do two copies of this. So we're going to have a second copy over here. And also, just like the product rule, in the first copy, we're going to apply the derivative to the first part. And then in the second copy, we're going to apply the derivative to the second part. Now, the main difference here is, unlike the product rule, we're going to put subtraction there in the middle. And so with quotient rule, because of this subtraction sign, the order matters. This term has to come first. This has to come second because we're subtracting. We don't have that issue with product rule, though. So this is very similar to how the product rule looks. The only difference here is with the minus sign. And then we have a big fraction, and then we just square the original denominator. So that's going to be our quotient rule. That's kind of the step we're going to be using. So we're going to write our quotient as a product, 2 copies, top function times the bottom function, top function times the bottom function. Apply the derivative to the first part, apply the derivative to the second part, subtract, and then we draw a big fraction and square the original denominator. All right, so another way to think of the quotient rule is there's various ways. You could just remember the formula. There is a little rhyme. So, if you like a little rhyming with your math, there's a way to remember the quotient rule. So it's, what is it? Low D high minus high D low. And then right down the middle there, we're going to draw the line. And then you square the low. So low D high minus high D low, draw the line, square the low. And what we're doing here is it's the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function. And then we have our big fraction, and we square the bottom. All right, so that's another way to remember the quotient rule. And so the quotient rule also comes with a similar warning. So it's very tempting, but wrong, to say that if we have a fraction, f of x divided by s, and we wanted to differentiate this whole quotient, it would be very tempting to say that it's the derivative of just the top function divided by the derivative of just the bottom function. So it's very tempting to do that, just kind of like what we were saying with the product rule, but this is incorrect. So that's not equal. They're not equal to each other. So we can't do that. So instead, when we have a fraction, there's this more involved formula that we have to use, which we call the quotient rule. All right, so let's try it out at an example. Let's look at this function x over 2x plus 3. And so first of all, when we have a function and we see a fraction, we kind of want to diagnose what's going on. So when we look at this thing, there is a variable term on the top. So we do have a function of x on the top of our function. And then also in the denominator, we also have an x term. So there's a function of x down there. So this is, and actually right down the middle, we have division. So we're dividing two functions of x. So we have one function of x on the top, we're dividing, and then we have another function of x in the denominator. And this is kind of an important thing to note. We have two functions of x here. So if we wanted to differentiate this, because we're dividing two functions of x, well, we got to use the quotient rule. So let's see how the quotient rule works. So we're going to calculate y prime. And the way we're going to implement the quotient rule, let's write down our quotient as a product. So we'll do top function times the bottom function. And then we're going to do two copies of that. So top function times the bottom function. In the first copy, we'll apply the derivative to the first part. In the second copy, we'll apply the derivative to the second part. And then with quotient rule, we put a minus sign right in between. And then we're going to make a big fraction here, and we're going to square the original denominator. So 2x plus 3 squared. And at this point, we've kind of differentiated our way through the fraction here, and now we just have these two smaller derivatives to do. And these are things that we can do with just our regular rules. So derivative of x is 1. And then the 2x plus 3 here is outside the brackets, so we're done with that. We have minus x, that's outside the brackets, so we're done with that. And then we just need to differentiate this 2x plus 3. And derivative of 2x is just 2, and derivative of the 3 all by itself there is just 0. So we get 2. And this is all over 2x plus 3 squared. And technically, we're done. We found our derivative. Now, when we simplify this, if we were to simplify this, there's a little bit we could do. So first of all, we don't normally write multiplication by 1. And you want to try to simplify the numerator first. And one thing to note, something that I see enough where I think it's worth mentioning, and you might be thinking it right now, this 2x plus 3 is not going to cancel out with that 2x plus 3 in the denominator if we wanted to simplify this down. And the reason is because we have this additional term here in the numerator that we're subtracting off. So when we simplify these quotients after we've done the quotient rule, we have to go through and simplify the numerator first before we try doing any of this canceling. And normally what we find in most cases, not all, but in a lot of cases, is it's not going to cancel off so nicely. So it's going to be very tempting. You see a 2x plus 3 right here, 2x plus 3 down here. Let's get rid of them. Can't do it. Instead, we got to work with the numerator first. And actually, we don't do anything normally with the denominator. So, usually it's a good idea. Don't multiply this out. Just leave it as 2x plus 3 squared. So just a few notes. Simplify numerator first, if you did want to simplify this down. And usually the second one here is really just leave the denominator alone. So don't multiply out that denominator. Tempting, but usually it's not too helpful to do that. So how would this look? It's not necessary, but how would this look if we simplified it? Well, first of all, we'll get rid of that 1. We don't really write multiplication by 1. And then this x times 2, we could more commonly write that as 2x. And so what we have here is a 2x minus 2x. And so that's just going to leave us with plus 3. So this actually simplifies to just 3 over 2x plus 3 squared. And that's our simplified derivative. Okay, so that's the idea behind quotient rule. We're going to practice this more in class. So we'll see you then. Bye-bye.